Yep.
There you go.
Okay, well, thank you guys very much. How's the event going so far? Awesome. Awesome. They said it couldn't be done, but it happened. So now I'm going to flip out of organizer mode and tell you guys about scriptcs. How many people here have heard of scriptcs or used it? Fair number. And have you actually used it, or you're just aware of it? How many have used it actively? Okay, less of a number. Okay, good. Well, we'll be getting hands-on here. So I wanted to do something a little bit different, though, in this talk. I wanted to not just talk about the technology or the tool of scriptcs, but also the project, how we ran the project, how we grew it, what were the challenges that we went through. So we'll be a little bit different. And I also, even though we only have 30 minutes, feel free to ask questions as well. So just quickly about me, this is me. Well, this is my open source me on GitHub. Pretty active in a bunch of different projects. I work on open source stuff at work, but I also do quite a bit on the side. Scriptcs has actually become the soaker of a lot of my side time when I'm not with my family. So I have a lot of passion for scriptcs, which you'll hear about today. I work for a company called Splunk. We're actually one of the sponsors of this event. I have a bunch of shirts. If you want to get shirts, they're over there in all different kinds of sizes. We are basically an engine for machine data. So operational intelligence. If you have tons of servers and you want to be able to monitor what's happening on those servers real time, Splunk is a great product for that. It's used by some of the largest enterprises in the world. Highly scalable, very fast product. And it is useful for a bunch of different domains. 1/3 of our customers use us for security, actually. Security auditing, anomaly detection, these kind of things. We work really well on real-time streams of data. So when a lot of people think about us in comparison to, say, like Hadoop, we're not really for looking at massive historical data. We're all about being able to process massive amounts of data that are coming in real time and help you to figure out what's going on and reconcile. We also do have a developer platform, which I work on at Splunk. And we offer SDKs in 6 different languages, one of them, C#. Now, before I dive into talking about scriptcs, and the easiest way to describe what scriptcs is, it's a new way to write C#, a lightweight way to write C#. And I'm going to tell you a little bit about the story of how it happened and why it happened. But first, I'm going to give you a bit of what it is, and then we'll dive into some of the background behind it. Before I do that, so one of the things we can do with this product that I have, that I work on, is we can actually point it at external systems and pull down all of the data. So I've gone ahead and actually extended Splunk in C# to basically be able to talk to GitHub, and I've pointed it at the scriptcs repo, so you can see all the commits that have happened throughout scriptcs project lifetime. And that's actually useful because what I can do then is I can do things like look at statistics. Let's see here. So this is going to show me a time chart over time of people that have committed to the project. So you can actually see, for example, if I tend to come in waves, so you can see some of those tendencies there, that I'll like come in and I'll be really strong for a while, then I'll go off and I'll be kind of quiet. Then Philip, who's one of our core contributors, he's kind of been pretty steady. And then we have Adam, who fairly recently joined the project, who's been exploding in activity. So that's one of the things that you can do with that product. But another thing you could do with it is, because I've mined all this commit data, I could find, let's say, that stupid bug. And we actually have a bug that has a comment that is a stupid bug. So there you go. That's one of the things that Splunk allows you to do, is look for needles in a haystack. So I put the scriptcs data in there. Moving on. So scriptcs is a lightweight way to develop C#, and it's really inspired by these. Inspired by the kinds of experiences you have if you develop in Ruby, if you develop in Python, if you develop in Node. Anyone here has done any of those? So what's different about those kind of stacks? What's unique? Thinking about how we develop C#. Can anybody tell me? REPL? Okay, that's an interesting one. What else? Scripted. What do you mean by that? Exactly. And do you need an IDE to develop it? Right. So these are the things. Now, I'm not up here to be against IDEs. I'm not at all against IDEs. But sometimes there's things that you want to do, you just want to get going really, really quickly. And what you find when you look at some of these other stacks is, hey, all I need to do is just go in a folder, type a file, open my editor of choice, and I can go. And so really what scriptcs was aiming to do is bring a similar kind of experience. Now, for a long time, this just wasn't really possible. There wasn't a good set of, we didn't have one of the things that was really prominent in each of these worlds is the notion of package managers. So in Ruby, you have Ruby gems, and in Python, you have pip and all these other solutions. And then for Node, of course, you have NPM. So this was a big missing factor in the Microsoft ecosystem for a long time. In the .NET, I don't want to call it the Microsoft ecosystem, I'll say the .NET ecosystem, apologies. But no longer. Now we actually have Nuget. So scriptcs is very much a tool that is based on a lot of the progress that has happened in the .NET platform over the years. And it uses primarily two technologies, its foundation. It uses Roslyn. How many people here are familiar with Roslyn? Okay, so Roslyn is a managed compiler. And one of the things that's nice about Roslyn, at least in the CTP stage, and now this is actually coming, is the fact that it offers a scripty model. It offers a way to execute C# code without having to have even a class. You can just write some loose code, which is really what you're used to in a lot of these other stacks. And we've got amazing package management now with Nuget. How many people here don't use Nuget? There you go. There's the answer. Or they're too ashamed to admit it. But reality of it is, Nuget has become such a central part of how we develop. So those are two core components that really play in to what enables scriptcs to be possible. But when we first really started out with scriptcs, right away we had a lot of people saying, well, what about Linux? What if I want to do stuff on the Mac? Do I have to launch a VM to do it? Initially, you did. But we also do support this guy. So you can actually use scriptcs in a cross-platform way. Soon, that won't actually matter because our friends over on the Roslyn team are going to make sure that Roslyn will work cross-platform. But we've had amazing support from folks from the Mono community in helping us to really get a good Mono story. Our Mono story is not 100% parity-wise, but it actually has some things that you can't do today in the CTP bits that were built on, like async await and dynamic were not available in the early Roslyn bits that we built on top of. So Mono actually opened that up for us, which was really awesome. But again, the direction that the platform is headed, it's not going to matter. We'll have one compiler, and we'll have one runtime, ultimately, that you can use across all these different stacks, which is really awesome stuff. So before I get into this adventure and how this thing got started, I thought we'll just jump in and take a look at what scriptcs is. And I'm going to show you a bunch of different samples. So the first thing you have to do, you need to install scriptcs. Now, is scriptcs a tool? Is it a library? Both. There's a tool, and there's a set of libraries that the tool is actually built on top of, and you can use those libraries directly, and I'm going to show you examples of what you can actually do with that. But the primary user of scriptcs thinks about it as, hey, I just want to write some code, some script code, and I need a tool to be able to do that. And scriptcs is that tool. And you guys might see the shirt that I'm wearing says chocolatey. So the easiest way to actually get scriptcs is you can go and use a tool called Chocolatey, which Rob is here, who'll be giving a talk from Puppet on Chocolatey. And if you go to Chocolatey scriptcs, you can basically just type one command if you have Chocolatey installed on your machine, and you get scriptcs installed. That is for Windows only today. That's not, I said today. That's not something you can do. But we also are now available in Brew. So you can also, if you're on a Mac, you can do Brew install scriptcs, and you can get scriptcs that way as well, which will actually use mono. But there's another tool that recently came on the scene that one of our core team wrote, and that is called SVM, and I'm here to tell you about SVM. So SVM is the scriptcs version manager. So if you go into the Ruby world, they were kind of the first one, I think, that really pushed this. There's a tool called RVM. And why is RVM useful? Because you want to test out, you want to be able to run different versions, or as new versions come out, you want to quickly and easily be able to install them. But you might also be testing different versions. Like, you're in your company, you might have something that builds on version this, and you want to make sure it also works for backward compat. So SVM is a really awesome tool that does that. SVM also works on Mac and on Windows. So when you just run SVM, you can do something like SVM list, and you can see all my different versions of scriptcs that are here. And my favorite feature, which Paul added for me, Paul Boer, who's the person who wrote this, is the fact that SVM will allow you to also mount local versions. So as I'm developing, I'm building release builds, I'm building debug builds. I actually work on scriptcs. So this is only really interesting to you if you plan on doing a patch or add a feature to scriptcs. But it really, really helps the workflow, because what you can basically do is SVM use debug. And once I do SVM use debug, I'm now actually pointed to the folder where I'm compiling to. So it's really, really cool. Really, really cool stuff. All right, so what you can also do, though, with SVM is you can actually download versions dynamically. So we publish a new version of scriptcs instantly now. SVM will actually see that and make that available. So if I do install-L, you can see that it says these are all the versions that are available. And then I can jump easily between them as well. So if I go now, this is the latest version that just came out. If I do SVM use 0.14.1, I'm now using the active version. And this model of having package managers is also something that Microsoft is really embracing. So if you look at the new stuff, DNX, they have this tool, KVM, I don't know if it's been renamed yet, which allows you to jump between different versions of the new .NET runtime, which is very easily bin deployable, which is a really, really nice thing. Now, before I go a little further, one question you might have is, so does scriptcs just install simply by installing scriptcs on the machine and that's it? The answer is no. You need to have either the .NET runtime or the mono runtime. You can actually use the mono runtime on Windows as well. The nice thing, though, of where we come closer to kind of the node model is the fact that if you already have .NET, which the majority of machines that you're going to touch already do, we're a very small install on top of that. Another thing that we embrace is this idea that keep the core very small, everything else is a package. So let's get in and take a look at some of the things that you can do. Now, somebody mentioned REPL. So a REPL is an interactive environment. You just want to type code. You could say, oh, well, Glenn, I could do that in the immediate window. Yeah, if I fire up Visual Studio, create a project, all of that other stuff, sure, you can do that. But with scriptcs, what you can actually do is just run scriptcs. And now I'm in a REPL, and I could say console.writeline hello.NET Fringe. I'm in a VM, so maybe a little slow. Okay, so there you go. I'm in a REPL. I just wanted to run some code. That worked. I can also define variables. So I could say var A equals hello.NET Fringe. I can dump that variable right in the REPL, or I could reuse it as part of my code that I'm running. Following with me so far? I can even define functions in line. So I could say, hey, I'm going to define a function called greet. And it's going to take a parameter of message. And I'm going to write console.writeLine. I love this greeting thing. I think it's from my WCF days. The samples in WCF were often like these say examples that just write you back a message. Yes, I did work at Microsoft at one point. So now I'm going to close that off. And when I close that off, I now have a local function that I can use that I just defined inline from within my REPL. Okay? So you're following with me so far. You're not constrained only to the REPL, but I want you to get the power of the REPL. Now what else can I do with this? So I can write basically any kind of .NET code. Now today if you use our CTP, you do have two limitations. You can't use async await, and you can't, if you're built on top of the Roslyn CTP, sorry, not our CTP. And you cannot use dynamic. For async await, it's not a big deal in the REPL because you can just take the task and access the result. I'm actually going to show you that in a second. But as I mentioned, if you use our mono engine, you can use both. And that will change. So okay, so this is kind of cool. So I can run some code locally. Now I can also reference DLLs right from within the REPL. And I can get things from the GAC as well. So like let's say I actually wanted to use, ADO.NET. I can do a $R, and once I do a $R, and a lot of this we took from the Roslyn syntax. Roslyn actually has a syntax, and this notion of these things called directives. And $R is a way to do a reference. And what we made is that if you just give us a name, like that will automatically go to the GAC and grab that from the GAC. But you can also do local DLLs as well. So that's one thing. But what if I want to construct like a complex object? Like here I'm doing this greeter. Yeah, it's kind of cool. So .NET has this thing called an HTTP client. And you can make HTTP requests with it. Well, if I could do that in the REPL, I could do some interesting things like interacting with websites, calling APIs, things like that, right? Yes. So what I'm going to do now is I'm going to say new HTTP client. So I now have a client instance. You can see the default properties here. We use JSON.NET, by the way, under the covers as our serialization mechanism for dumping things in the REPL. So now that I have that client, I could actually make a request. So I could say, I'm going to make a request to my company's website, Splunk. So I'll go www.splunk.com. Now, I don't have async await here, but I can do .result. And now you can see that I actually was able to make this call. And from that result, that response that I got back, that response message, I can then access the content. And I could say read as string async, for example. And I'll use result on that as well. Okay, so I made an HTTP request, I took the response, I dumped those results out. All happen interactively in the REPL. You getting a sense of the kind of things that you can do with this? This is just one example, but you can pretty much do anything. We have somebody wrote an extension for Azure. You want to manage your Azure. A lot of people have looked at this from a kind of DevOps-y kind of scenario. That actually was not my goal when I built it, but that was, the community takes it where it will. And they were like, hey, there's a lot of things, for example, the big elephant in the room will be PowerShell. I've had a lot of devs say, well, PowerShell is really cool, but I have to learn a whole new way of doing things. And I can actually imagine a lot of those things that I do in PowerShell, if I just think of how to do them in C#, it's real easy for me to do that. So we've seen a lot of people using this for automation. Now, how does that work if I'm living in the REPL? Well, the REPL is just one angle of using scriptcs. Scriptcs's real power, in my mind, is the fact that you can actually create scripts just like you would expect with something like Node, and you can then launch those scripts. So let me show you an example of that. So this is Sublime, And one of the things we have that's pretty cool with Sublime is we actually have a Sublime plugin that you can get for scriptcs, which will give you syntax highlighting and autocomplete for some common things, or not even autocomplete, more lightweight scaffolding. So here you can see that I wrote a class called greeter. No namespace. That's a key thing about scriptcs. There are no namespaces. And that's because both the way Mono and Roslyn work, these get rewritten into an outer class. Because the .NET runtime still expects you to give it a proper type. A lot of this stuff that scriptcs is doing is just a syntactic sugar. So you can see here that I've now created this greeter class, and then I've got this file called start.csx. And in it, I've added this thing called #load. And there's our greeter again. I'm newing up the greeter even though I actually haven't included it locally, because I'm using this #load, and that #load is kind of like an include. It's using that load directive. Once I have that greeter instance, then I can call greeter.greet, and it will work. So let's see that happen. So the way I do that is, instead of just running scriptcs by itself, I could do scriptcs start.csx. So, and #loads can be nested at any level. So you can start to get a quite complicated type of app, if you want to call it an app, that's all authored in script. It doesn't have to be in one gigantic file. You can split it out and refactor it, etc. Another cool thing we have is the watch parameter. So what the watch parameter will do is it's now going to watch this file to see if any changes happen, and if I make a change and save it, it will automatically tear it down. So that's really cool for iterative development. And so what we've seen is like, and I'm going to show you a little bit about how you can even build web apps with this, like Nancy that Adam mentioned, is the fact that people really like that ability to be able to iterate really, really quickly. They might be writing something in scriptcs that ultimately they will port to a full .NET app. But what scriptcs does is cut down on a lot of the tasks of just cracking out code and getting stuff going, getting it to a point where they can have something working really quickly without having to manage like building a project, building all that other stuff. All right, so, okay, kind of seen now how we can include from the GAC, we can do all these different things, we can use like HTTP client, we can launch script files. So how can we put all that stuff together? Now this one will be interesting to see how you guys react to it. Once it starts. So this is a WPF calculator defined completely in script. And this is more sophisticated than just a console.writeline. I've got a bunch of different script files, I've got a view model, but it's all defined in script. Now, the question you may have is, when that's running, how fast is it? And the point is that, think of scriptcs as a compiler and an executor, but once that thing is compiled, it's an assembly in memory. It's no different than that assembly that you would have built yourself. So it's not like it's going to be 10 times slower once it's actually running. It's the same .NET code. We're not rewriting any of the .NET code. So you can see here that I actually have a view model base. I've defined a view model class. And I have a relay command for any of you guys that are used to working with view model stuff before. And then here's my calculator view model. So I've actually defined a view model completely in script. So you can go pretty far with this. All right. Let me just run that one more time. All right. So, what about Nuget packages? I said the key thing here was that you can actually use Nuget. So scriptcs has a command called install. And if I type scriptcs-install, for example, automapper, then it will go out to Nuget and find the automapper package and install it. But it does something else. Once that automapper package is available, it does a conventional-based thing of saying, okay, I will automatically load it. So I don't have to like specify that I want it. It's just there by virtue of the fact that I installed it. So if we take a look at this Nancy sample, you'll notice that I have this scriptcs packages folder. Oh, sorry. And that packages folder has within it a bunch of stuff, Nancy packages and things like that. So if I run scriptcs start.csx, you'll see that in a couple of seconds I have a Nancy server up and running. So if you like Nancy, you can do Nancy development completely from scriptcs, and you can combine using that watcher, and then as you make changes in your pages, instantly the server tears down and reopens. So let's see it actually running. There you go. So that's a Nancy app being served up from scriptcs. Okay, we're running out of time. One of the things we have done is we found that there's a lot of frameworks that are just difficult to work with when you start to bring them in a scripting world, because when we work in Visual Studio, there's a lot of things that VS takes care of for us. It does a lot of code gen. We get using statements and things automatically ingested. And when we started to look at doing these kind of things in scriptcs, we found that code just started to explode. For example, just these using statements are necessary for doing like a Nancy autofac app. That's a lot of code for me to have to write and remember. And then we had to do all kinds of interesting hackery with the bootstrapper in Nancy so that it could support dynamically emitted assemblies. So we have this model in scriptcs called script packs. So if you look at this example with all this different code here and all these different files, if you use a script pack, it evaporates to this. So we introduce in scriptcs this command called require of t. And what the script pack does is it has a life cycle. It has an opportunity to inject using statements, to inject references, to set up things like the Nancy host for you. So it just makes the code much, much easier. You can find much more about our script packs if you go to github.com/scriptcs. You'll see there's a wiki page where we actually have a lot of these script packs listed. There's one for Service Stack, Raven DB. There's a whole bunch of different ones that are out there that the community has created. All right. So I am almost out of time, so I want to quickly flesh through the rest of these before I'm booted. How did this start? Well, I think I told you. I wanted to basically find like a node-like experience for C# development. But for me, this really was like the holy grail. I wanted this for like 10 years. And I started doing node development for like 3 years. And I found that I was not working in an IDE. I was working with a text editor and being really, really productive, which was an amazing experience. So I threw this sample out there, got a really good reaction on the sample. So what did I do next? I got terrified. I was like, there's so many dead projects out there. I don't want to be another dead project. It's a cool idea, but how do I make it not be something that's going to die? So what I basically did, I formed a team. I reached out to Philip and Justin. Justin will actually be giving a talk today on Roslyn or with Nuget. I forget what the exact topic is, but he's going to give a really interesting talk. I reached out to them and we said, hey, I said, and I knew that these guys were interested in this, and we joined up together and we said, let's make this thing real. And we went and created our own GitHub organization. We created a mailing list. And the cool thing about this was I realized that my own worst enemy, if I went on this myself, was going to be me. I needed to remove myself as a bottleneck. So fortunately, I had these great guys who joined us, and that over time, our team has grown. We have about 7 folks, all very active. And the nice thing there is there's always someone from scriptcs around to help. There's always one of us working on something to take it forward. And this is fully open source, and the community has really joined in. So we have about 60 contributors who've been contributing, and probably about 20 of them are really active. So if you have any interest in, one, getting involved with a project that would love to have you helping us out, go to github.com/scriptcs/scriptcs. Also remember that you can get this on Chocolatey. and you can also get SVM. Very last thing before I get booted is what's next. So the Roslyn team has been pretty awesome, and they've been trying to really take Roslyn forward. For a while, it was just in the CTP state. They're working with us, and we're going to have a proper story for scriptcs built on top of the latest Roslyn bits, which hopefully, Casey, will ultimately be cross-platform. We are also working with the Visual Studio team. They want to find a way to embrace scriptcs within VS. This is awesome. This is awesome to see Microsoft taking these kind of steps, and we really appreciate it and applaud them for the work that they're doing. And they are going to actively contribute back, they've told us, to our REPL experience to give us VS-style IntelliSense and syntax highlighting. So this project is no longer just a pet project, and you're going to see more and more about this, and we would love to have you involved. And thank you guys very, very much.